Hey guys, Buildzoid here with another PCB breakdown for you, and today we're going to be taking a look at the Maximus XI Apex, and I really like this motherboard. And this motherboard makes me dislike the rest of the Maximus XI lineup even more than I already did. So let's just go over some interesting things worth knowing. So this board, the Apex, right? Apex right here, it's 330 pounds. So 330 GBP. The formula, which I'm just going to write form, is 400. Yeah, 400. The code is 350. And the extreme is 450. And the funny thing is that if we ignore the fact that this can't power iGPUs and only has 2 DIMM slots, this right here is better than all of those. Like, this is a better motherboard than all of these. And the best part is, it's cheaper than all of the other 3 boards that I just listed off. And in fact, the funny thing is, the Hero is actually not that much cheaper. The Hero is at least in the UK, it's 290. So, ASUS WTF, right? Like, what? Why are all these terrible boards so close in price to a really good board? Well, this one's not so bad, but it's a bit overpriced considering the price point of the Apex, but these are just bad. Those are just straight up bad. As far as I'm concerned, this, like, I don't know why you'd ever buy these. Do you like wasting? I mean, actually, no. If you buy Apple laptops and other Apple products because they look nice, then yes, I can totally understand why you'd buy these 2 boards. But other than that, there's literally no reason to get those. So anyway, let's get onto this motherboard and why it is that I like it so much. So before we get into the Vrm, which as you can clearly see is substantial, there's a ton of overclocking features on it. So we have these white fan headers, which are for, basically they're full speed fan headers. So any fan you plug into these is just going to run at maximum RPM all the time, which is great if you're running, if you're doing benchmarking, because it saves you time from not having to go into the BIOS and max out all your fans. You just plug them in and bam, they're maxed out. So that's nice. We have dual 8-pin power connectors, which is completely, like, it's not necessary unless you're on, like, unless you're on liquid nitrogen. And we get some more fan headers, and, oh, this chip's kind of neat. I can't actually remember what exactly it is, but the idea behind, like, ASUS uses this chip to improve the accuracy of the software voltage sensing from your Super I/O chip. So if you remember, I did a video with a Gigabyte motherboard recently where I was like, oh yeah, you need to, if you want the accurate voltage reading of from the motherboard, then you want to look at the VR Vout measurement from the International Rectifier IR35201 voltage controller. Well, ASUS basically has this chip right here which fixes the accuracy and connects the Super I/O to the proper voltage sense lines to get a proper measurement. So essentially on an ASUS motherboard, I don't think they actually expose the voltage sensor of the ASP1405, so you couldn't do the same thing as on Gigabyte. But basically, if you just check the VCore reading from the Super I/O, it's actually accurate because of this chip. So that's that's a cool feature that, you know, all ROG boards since the Crosshair actually, well, no, let's not misspeak. I'm not sure that the Strix boards have it, but like the real ROG boards, because the Strix boards are watered down ROG boards, and I'd say even the Hero and the Formula and the Code are starting to be watered down ROG boards, but at least they still have this. So anyways, like the main ROG boards, they all of those have that, and that's a pretty cool feature, and they have it since like the Crosshair 7 Hero for the AM4 socket. So that's a neat feature. Then we have some RGB crap, more fan headers, another full speed one, postcode, debug LEDs. So, you know, if you don't want to bother reading the postcode, you can get a rough indication of what's wrong. And these are actually color coded. A lot of other board vendors have them like in one color, which makes them kind of not very helpful because you're going to be trying to figure out which LED lit up rather than, you know, at that point, you might as well just learn the postcodes instead of trying to figure out which LED is lighting up. Because if you have DRAM, CPU, VGA, boot, right next to each other and one lights up, well, it's like, well, which of the 4 LEDs lit up? You can't tell because, you know, it's blinding you whenever you look at it. And ASUS does have these color-coded, so you can just tell by what color is lighting up, so that's nice. Then we have the Memo K switch, which is made entirely redundant by the Safe Boot button, and also, this thing, if you have it turned on, makes, at least in my experience, it makes the board worse at training hard memory settings. It doesn't make it better, so I would turn that off and not use it. That's been my experience with it so far on the Maximus XI Gene. Just turn it off, never ever switch it on again. Next, we get a power button and a reset button, so that's nice. You know, well, that's standard for an extreme overclocking motherboard. Then we get voltage read points. These are actually hooked up correctly, so if you, like, measure the V-core across this, that's actually measuring the V-core on the CPU package, not, you know, somewhere in the power plane. So that's great. That's nice and accurate. So you can trust the voltage readings from those. Then we have a retry button and a safe boot button, and I'm not sure which one of them is which because I can't see the label on the board, and I didn't bother to write down which one is which. So that's that. But you do have a safe boot and retry. Retry basically forces the board to power cycle, even if it locks up so hard that the reset button doesn't work. You hit retry, it'll power cycle the board anyway. So very useful when training hard memory settings or when the system locks up to the point that the reset doesn't work, which does occasionally happen when pushing really hard memory settings and like cache settings. So yeah, that's nice that you have retry. And then safe boot basically allows you to get into the BIOS even if you have settings that don't post. So if you have settings that won't post, you can just hit the safe boot, you get into the BIOS. It doesn't wipe the BIOS, which is the super useful part. So you don't need to really save profiles because the safe boot button has your back. So very useful feature right there as well. It's also convenient if you like forget to configure your Windows. Like what I tend to do with safe boot is like I'll have really, you know, hard memory settings set up and I'll forget to like set maxmem in Windows 10 in Windows. So you can just safe boot into Windows, set your maxmem and then restart. And bam, like you don't need to, you know, go back to safe defaults, set maxmem, apply your profile again. You can just use a safe boot to do that. So that's pretty neat. And we of course have the 24 pin, another fan header, a USB 3.1 front case header. I honestly don't keep track that much of like what case function out features are. So we get a USB 3.0, some SATA ports, and then we get the pause switch. This is kind of neat. You can basically lock up the system on demand. And by lock up, like temporarily lock it up. Like you can literally just stop the system temporarily, stop the system from doing anything. Time still passes while that is active, so your timekeeping is still going to be correct. But you can basically, like, if you want to change settings on a loading screen, which I'm not sure how you'd actually do that on this motherboard because I can't see a connector for the ROG OC panel unless that thing can do that, but I'm not sure. So anyway, but when on other boards where you had the ROG OC panel, you could basically pause, change the CPU ratio while on like a loading screen, and then unpause and bam. Right, you'd have different CPU settings for a different part of the benchmark, which is kind of like, that's a pretty neat feature. Then we get slow mode, which is really convenient if you're just sitting on desktop doing random crap while on liquid nitrogen. You can have slow mode engaged, which forces the CPU to the lowest CPU ratio, which means you're not going to crash. You're also not going to waste a bunch of liquid nitrogen just, you know, idling at 6 gigahertz because your power consumption is relatively linear with frequency. So going from 6 gigahertz to like a gigahertz cuts your idle power consumption to, you know, 1/6. Well, can cut your idle power consumption by as much as 1/6. So yeah, that's a really nice feature when you're on Ln2. For daily usage, it's kind of irrelevant. And then we have a reserved switch and a Ln2 Mode Jumper. So the Ln2 Mode Jumper basically lifts a bunch of voltage restrictions, and it also presets a bunch of settings for you. So it's actually kind of like, if I remember correctly, there's like 1 or 2 voltages that this configures to unsafe levels if you don't manually set them and leave them on auto and you're on ambient and you have to switch this on. It might, like, not the best idea to do that. Reserved switch here, if you have Ln2 mode enabled, the reserved switch preloads a bunch of, well, typically it'll preload a bunch of voltage settings for cold boot bug removal. Very, very handy if you're benching on Ln2. It may not work correctly on all CPUs, And if you try to enable that while on ambient settings, it'll just stop the system from posting. And it's also not good for the CPU when you do that, if it's still ambient. So yeah, so those are basically a bunch of extreme overclocking only features. Then we have a BIOS switch because this board has dual BIOS. Yes! Yes! So yeah, you do have dual BIOS on this board. It's right here. There's also LEDs for indicating which BIOS chip is active. So yay! Proper extreme overclocking features are back on motherboards. Well, more like back in fashion, I guess. Fun fact, the Maximus XI Gene, which has a bunch of the extreme overclocking switches, doesn't have dual BIOS. I got really annoyed when I realized that. Anyway, oh yeah, and then we have another... oh, it's meant for like AIO pumps, but honestly, I often use it just for another full speed fan header because it does that as well. Down here we have a front panel header, more fan headers. Like this board has a lot of fan headers for an extreme overclocking board. Another full speed one, of course. USB node thing, which I've not bothered to check. I tried Googling that, didn't really find anything immediately like useful to me. So I just, it's a thing. You can look it up yourself if you want to know what it does. And then we have the Molex extra PCIe power connector. And here's the thing. I think that just, this should be a 6-pin. Like, seriously, this should just be a 6-pin. At least it's not in, like, here. Like, a lot of board vendors, when they add a power connector for extra PCIe slot power, they put it right here, which is just stupid. Like, that's the worst place to put it, because then you have a wire just running right... Like, where do you route that wire? Right? Even if you're on a test bench, where do you route that wire? Because going through this area, like you're going through the I/O area of the GPU and the motherboard. Like, this is stupid. Putting it right here. So this is the correct position to put this. It's the wrong connector. I hate the Molex connector. It's awful. This should be a 6-pin. So that's kind of that. Then we have front panel audio and the usual isolation, you know, indication line for the audio section right there. And that's pretty normal. So, that kind of covers the, you know, basic features side of this motherboard. Now let's cover the VRMs. Let's get on to those. So, this board is the first board in a long time to feature a new VRM for ASUS. And it's a monstrosity. It's a giant 8-phase. Yeah, I know it looks like a 16, but ASUS is still doing the... Like ASUS still doesn't want to use doublers, which I think for Z390, yeah, sure, knock yourself out. I don't see why you'd need doublers here. In fact, I'm not sure why you'd need an 8-phase this big either, but I will say I do appreciate that, you know. Like, well, I guess the logic was we want an 8-phase for its reduced output ripple and its reduced input ripple, but it's like we want more current capability than 60 amp per phase. So we have 120 amps per phase, or at least roughly 120 amps. It doesn't quite work out like that because there's going to be difference between the slight differences between the power stages, and so they're not going to like perfectly current balance themselves, but still, you basically get a ridiculous amount of current capability per phase here. So the voltage controller used here is an ASP 1405, which is the which is probably, and that's not a 5, but that's probably a 35201, well, IR 35201, or if it's not exactly a 35201, it's a very slightly modified 35201 for ASUS's usage. Also, that is a very small input filtering inductor. I've just realized. But yeah, I mean, it's fine. It's like, it's not going to be pushing that much current. Again, Z390, but anyway, so yeah, we have the ASP 1405, and here it's running an 8+0 configuration. And this is another thing I'd like to draw attention to. The ASP 1405, the only board in this group right here that uses the 1405 is this board right here, right? So that also uses an ASP 1405, and that uses an ASP 1405. Why don't these? Also, the Extreme uses it as a 5+2, and the Apex uses it as an 8+0. So, like, honestly, I think the VRM off of the Extreme should also be at least on the formula and the code, if not even also the hero, because evidently ASUS can make a gigantic 8-phase for 330 quid, while also adding a whole bunch of extreme overclocking features onto the board that all of the, well, not the Extreme, but the hero lacks those. The form and the formula and the code don't really have them either. Like, they have some of them, but not all of them. So, yeah, it's just like, this is why, like, I really like this, the Apex board. But the Apex makes me like the rest of ASUS's lineup even less, because it's just, like ASUS is basically admitting that they're ripping you, like, these are overpriced, right? Because the Apex is just far superior to both of those and cheaper. Which is just like, yeah, I don't know how that works. So, anyway, we do just get a giant V-Core VRM because they did decide that they don't really want to bother with powering the iGPU, because if you want to run the ASP1405 and 8+0, if you also wanted to power the iGPU, at that point you'd have to buy another voltage controller, and that gets really, really expensive very, very quickly. And this being an extreme overclocking targeted board, extreme overclockers generally turn the iGPU off because there's a voltage that you need to raise, while on Ln2 that tends to blow up iGPUs. So you normally don't have the iGPU enabled when extreme overclocking anyway, because if it is enabled, it dies. So, yeah, anyway, for the actual power stages in our massive 8-phase, we are looking at the ASUS favorite component, the IR3555. Which is a 60 amp power IR stage. So, you know, it integrates current monitoring, temperature monitoring, body braking mode. It has a bunch of pretty cool features that make it a bit special than like your bog standard 60, like a regular 60 amp power stage. So those are pretty neat. ASUS likes to use them pretty much not everywhere, because this has worse power stages, that has worse power stages, that has worse power stages. The Extreme also uses the 3555s, and the Gene also uses the 3555s. So these are great, and ASUS has a ton of them here, which is how we get that, you know, almost 120 amps per phase current capability. And basically, like, this VRM is just awesome. Like, seriously, it is super awesome. Now, the issue, though, is that since these are 60 amp power stages, and there is 16 of them here, your low load efficiency with this entire VRM running is actually not that great, because, well, these things hit peak efficiency at around 15 amps output. 15 amps times 16 is over 250 amps output, which you're just not going to hit on an ambient 9900K. So basically, if you're running this entire VRM, like when this entire VRM is running, at normal 9900K load levels, it is actually below the peak of its efficiency curve. So, like, I'm a huge fan of this VRM, but efficiency-wise, it's not optimal because it has too many phases. And this is an issue that a lot of the sort of extreme, like, a lot of the ridiculous Z390 boards kind of run into. Like, for example, the Gigabyte Z390 Aorus Extreme board, same problem. It has a 16 phase using 60 amp power stages, and basically up until, like, honestly, like, for optimal efficiency, that board should never run with more than 12 phases active, right? And it's just like, well, oh yeah, this is not a 16 phase, it's a 16 power stage, but still, same issue, right? So, too many phases, not enough power consumption. I mean, too many power stages, not enough power consumption. Though, arguably, you could just turn off, 4 power stages in 2 phases and then run this as a 6-phase, but to get the better efficiency. But anyway, so let's talk about VRM heat dissipation figures based on current, as usual. So 1.35 volts output and 400 kilohertz switching frequency. And why is the writing now all squiggly? Now it's smooth again, isn't it? Oh, I don't know. Anyway, and 5 volts drive voltage, which these actually run optimally on higher drive voltages, but most board vendors don't bother with that because you get 5 volts from the 24 pin for free. And it's just easier to grab 5 volts from there instead of building a voltage regulator just to convert 12 volts into 5 volt into like 6 or 7 volts so that you can drive the power stages with a slightly higher voltage. Also, well, I'm actually not sure that that applies to the 3555s, but I have heard that at least for like 3553s, there are actually like reliability issues at higher drive voltages. So anyway, ultimately, it doesn't really make a huge, like, well, it does actually make a pretty big difference to the overall efficiency, but it doesn't really make a difference to the cooling requirements for the VRM, because this thing has, like, this is so large that, quite frankly, this doesn't need to ship with a heatsink. So if ASUS felt like making the Apex even cheaper, they could ship this board without a VRM heatsink at all, and quite frankly, this heatsink could have been smaller as well. And this wouldn't have to exist. Like, from an extreme overclocking perspective, this doesn't need to exist either. But anyway, let's talk about the efficiency here. So, 150 amps output, which is like, that's like normal 9900K overclocking. This is going to be producing about 18.8 watts of heat, which is not the highest efficiency achievable at that 150 amps output. Now, going up to 200 amps output, it gets 22.5 watts of heat. Again, not peak efficiency. I actually have, for comparison, figures off of the dark for some of these current levels, because for some reason I did the dark in steps of 100, and I did the Gene in, well, did this board in steps of 50. So, and I didn't realize until I finished my notes, and at that point I didn't feel like redoing the notes for the dark. So, the dark does 200 amps at about 18 watts. So that's the EVGA Z390 dark would do about 18 watts, because it has a 12-phase VRM, which is like, you know, it nails the peak efficiency of its power stages, whereas this thing basically doesn't hit peak efficiency until, well, until about 300 amps output. So let's keep going up. 250 amps output. This produces about 26.5 watts of heat, which, like, the cool thing about this VRM is, though, that, you know, that 22.5 watts of heat that's spread across so much surface area, like, you don't need a heatsink. Even for 200 amps, you just don't need a heatsink on this. If there's even a slight breeze going over this VRM, you don't need a heatsink, which is, like, I'm a fan of that, right? That's awesome. But it isn't necessarily the most efficient. Anyway, going up further in current, 300 amps, at this point, the VRM finally hits about 30 watts heat output, and the dark also does about 30 watts. So at this point, the dark starts rolling off in efficiency, while this keeps holding pretty strong. So we go up to 350 amps, at which point this thing, you know, does 35.5 watts, and I don't have a figure for the dark, so I'm just going to add a line like that to show the comparison. And then if we go up to 400 amps, which if you're doing extreme overclocking, you're probably going to top out in this range. Okay, 300 to 350 amps, not even. Okay, like, not even necessarily, because I've not heard of anybody having a 9900K pull, like, well, 400 amps, you'd need to be pushing, like, you know, close to 2 volts at 400 amps, and I've not heard of anybody running 2 volts on a 9900K. That would be like 800 watts, right? So, yeah, 9900Ks don't do that. But if Intel ever comes out with, like, well, I have heard rumors that Intel might come out with a 14 nanometer 10-core CPU. That might, like, at that point, this motherboard's VRM will make a lot of sense. Assuming that 10-core doesn't have a fully integrated voltage doesn't have an integrated voltage regulator. But anyway, so going up, we get that 400 amps, at which point this board will produce about 45 watts of heat, and this is where, you know, it starts beating the dark, where the dark does about 47. And then if we go all the way up to 500 amps, this does about 60 watts of heat, while the dark does 66. Right? So, and that gap is going to get steadily, like, it's going to get bigger faster and faster as you keep going up. So, yeah, this is a beast VRM. And the thing is, I think ASUS pretty much designed this voltage regulator for, like, X399 and X299, and then they just kind of smashed it onto this board, because why the hell not? And I'm a fan of that, okay? Like, I'm not gonna lie. Yeah, sure, it's not the most efficient setup, but I'm a fan of this VRM. This is a good VRM design. If we could see more of stuff like, more of this from ASUS, and less of that and that, I would really appreciate that. Okay. Admittedly, I understand that for like a hero, you would need the iGPU. You would want the iGPU to have power. So in that scenario, you know, there's nothing stopping you from just going from an 8+2 to like a 6+2, and then maybe just going like that, right? So you'd have like iGPU there, and then vCore on the rest of that. And that like, I'd still be a fan of that, right? In fact, that would get you better better efficiency in this in that range. But I'm really not a fan of what they have on the Hero and the Formula and the Code, as well as the Extreme. Like, I really don't get why they didn't run that as a 6. But, okay, well, that's fun. GIMP is being weird, as usual. And now it's broken. Give me a sec. But yeah, like this is a really solid VRM design. I just don't get why the rest of the Maximus XI lineup has garbage compared to this. Like, this is ridiculous overkill, okay? But the difference between this and like the Hero is like acceptable, and the Code is like acceptable, and the Formula is like acceptable, and then there's this, which is ridiculous overkill, and it's cheaper. And I'm just like, how do you do that? Like, what is wrong with you? Why have such, like, yeah, anyway, so I am a big fan of the VRM on this, but I'm not a big fan of, like, the Hero, the Formula, and the Code. Especially now that I've seen that ASUS can do this for less money than a bloody Code. Like, seriously. What is that? Anyway, moving on, we have the bog standard ASUS 2-phase memory power, which is fine. Like, this VRM has been fine. The issue is I actually don't know what MOSFETs those are. The controller is, as usual, the ASP1103. So that's just running in 2-phase mode. I'm not sure if that's a plus something. Really hard to get data sheets for really any ASUS voltage regulators. So, yeah, and we do see the new improved output filtering section. So you can see, like, we have all of these multi-layer ceramics over here, and we have a whole lot of what could be tantalums or aluminum polymers, and more ceramics in this area. And they're doing this for basically most of the Maximus XI lineup. So, you know, that's cool. It's a nice feature to have. It's more elaborate than, say, what you find on a lot of other boards. The board, being an extreme overclocking board, obviously has just one DIMM for each memory channel. So, you know, and that's done for optimal, basically, memory overclocking capabilities. I've talked about this in other videos. This is the best memory like DIMM configuration for maximum frequency, and generally also even best memory performance. So, yeah, this is a good this is a good memory setup. ASUS isn't doing anything as elaborate as, say, like EVGA with the dark. They're going for like surface mount memory slots. ASUS is just going for regular good old, you know, we can just about see it, good old through hole memory slots. But you know, like ASUS hasn't done surface mount memory slots ever, and they've still been really, really good at memory overclocking on their 1 DIMM per channel boards. So I assume that they know, they know what they're doing with this, right? They've been doing this for ages and ages and ages, and it's been working fine. So I'm not going to necessarily criticize that, but I'd like to see ASUS try out surface mount memory slots. Like, I'd like to see if it would make a difference for them, or if it wouldn't. I think it still would. Maybe it might not be as much of a difference as they'd want, and it might really increase the cost of the board, but still. You know, it does do the standard for an extreme overclocking motherboard, and that's really good enough, especially considering, like, that price point is actually really good as far as I'm concerned. Like, I was expecting 400, 500 quid for this board, and it's 330, so I'm actually surprised it's not way more expensive, especially considering the Gene is actually about the same price as well. And that one's also targeted at, somewhat targeted at extreme overclocking, so yeah. Solid memory setup right there, you know, standard for ASUS. And then in terms of VCCIO and VCCSA, I mean, VCCIO is this right here, which is that's an integrated buck converter. So that's a 10 amp TPS 51362. And that's just 10 amps, which is fine. VCCIO doesn't really pull a whole lot of current. And then for the VCCSA, we have this right here. And I assume that's the controller for it. And that's going to be an APW. And I'm basing, these are based off of what I have on the Gene, just because it doesn't make sense for them to redesign that. I mean, the voltage regulators themselves look the same. They've just changed the layout a bit. So that's going to be an APW 8723A. And that there is going to be, and the MOSFETs are going to be both for the high side and the low side, a 4C10B from On Semiconductor. And this is, again, fine for VCCSA. It's really not a high current rail, so you don't need to worry about that. For the extreme overclocking voltage rails, I'm actually not sure what's going on with those, because on, say, the Gene, they're all just crammed right here. But on this board, I guess one of them is that. That might be one of them. That might be one of them. Well, that's probably not one of them. These might be some of them. It's really like, I'm actually not sure where all of those are or what they are, but this is an Apex. It has them, I just can't see them. So that's kind of that. We don't need to worry about it. And generally, it doesn't really, like, they're not high current, and you don't need to worry. Like, the main thing is just setting them to the right voltage. They don't necessarily push a whole lot of power, so we don't need to worry about them that much, as far as I'm concerned. So they are present, I just don't know where they are. So yeah, that is the Maximus XI Apex. I really, really like this board. In fact, I like this board so much that I've been considering buying it, that I've been toying with the idea of buying it, but I already have a Gene, and I feel like, you know, I need to stop buying more stuff because it's gotten to the, like, I have a lot of hardware which just sits in its boxes because I don't have enough time to get around to it. And if I buy an Apex at this point, it's like I've still not used the dark. I have still not gotten around to messing around with the dark properly yet. So I really don't need another extreme overclocking Z390 board, as much as I like this one, right? Yeah, this is a really, really nice board. So if ASUS could, you know, apply the design philosophy used on this to the rest of their Maximus XI lineup, I would really appreciate that. I think that would be a good thing, because this is a proper board, whereas the Hero, the Code, and the Formula are, as far as I'm concerned, kind of basically rip-offs, because they're way too expensive relative to what you actually get in terms of the boards. They're not bad. It's just like, I feel like they're $20 to $50 too high in price, whereas this, well, I guess they do make the Apex look like an absolutely killer deal as a side effect of being so freaking expensive. But yeah, this is a serious board, and I'm a big fan of it. So yeah, the Apex. I mean, I've run out of things to talk about, so I guess we're gonna just end the video right here. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, there's Teespring and there's Patreon. You can check out the links to both of those down below. So yeah, those both help out immensely. And before I end this, I would just like to thank the guy who actually sent me the pictures of this board. So I have a friend, and he got sent this board. I think he got it for free. Unfortunately, he doesn't have a 9900K. He only has an 8350K, so that's why there's an 8350K i3 sitting in this. But yeah, this is an amazing board, and a huge thanks to him for providing the pictures, because I don't know how else I would actually, like, I don't think I'd be able to do this video without him. So yeah, and good job, ASUS. I like, you know, first Maximus, well, other than the, yeah, actually, no, I didn't really like the Gene that much either, because it lacks dual BIOS, and I still think it should have been, like, the Gene has the same VRM as the Extreme, so good job, ASUS, on finally making a Maximus XI board where, you know, I feel like, whoa, this is a hell of a motherboard, and I'm not getting ripped off to get it. So yeah, I really do like this, and I'll press the stop button at this point, because evidently I won't shut up otherwise.